Number 3. Now you remember we've solved 2 problems now, and we've used elimination, and we've also used substitution. There's a third method called graphical method, meaning you graph the 2 equations, look at where they cross, and that's your solution set. Hopefully this will lend some clarity to what we mean by what we're doing when we use the elimination and substitution method as well. So, looking at this, we have x plus y equals 3 and 2x plus 3y equals 6. We're simply going to graph those 2 equations. First thing I do is I lay out a couple of t-charts. One t-chart for this equation and one t-chart for this equation. We're going to use these t-charts to figure out where the points lay on that graph. I'm going to use, I don't know, 0 is a good one. It looks like 3 might be a good one, and -3 might be a good one. So I'm just going to use those, +3. I'm just going to use those 3 points to graph my equations. If I look at a -3 for x on this t-chart, I simply put a 3 in for x there, the -3 in for x right there, solve the equation to figure out what y is. So here we go. -3 plus y equals 3. That's me substituting a -3 in for that x. Now I solve this equation. If I add 3 to both sides, I get y equals 6. So when x is -3, right here, y is 6. And I plot that on my graph. -3, 6. I look at 0, so I put 0 in for x. 0 plus y equals 3. Well, that's pretty simple. Y equals 3. So when x is 0, y is 3. And then I put 3 in for x in the equation. I've run out of room right here, so I'm just going to do it right up here. 3 plus y equals 3. Well, what do I need to add to 3 to get 3? 0. Y has to equal 0 because 3 plus 0 is 3. So when x is 3, y is 0. I've got 3 different dots all in a line, and so I just grab a straight edge and draw my line. Make it nice and long so that I can make sure the other line, when I graph it, crosses it. Now let's focus on this side and this equation. One of the things I'm noticing happen here is you guys will put a couple of points in for x, but then you'll try to do it in your head. You won't substitute it in and then solve the equation. You just try to do it in your head. It's not working for you. Make sure you write it down. So if I put a -3 in for x right here, I get 2 times -3 plus 3y equals 6. All I did was put this -3 in for that x. 2 times a -3 is a -6. Another problem you guys are having is you're getting this put together perfectly, but then you're having a hard time solving the equation. So you're going to have to practice that. If I add 6 to both sides, I get 3y equals 12. I divide by 3 on both sides, and I get y equals 4. So when x is -3, y is 4. -3, 4, I plot that point, so I come over here -3, 4, and put a point in. The other thing I'm seeing is some of you are trying to put both equations on one t-chart. Each equation needs its own separate t-chart. It will create 2 different lines. So let's put 0 in for x. And down here I get 2 times 0 instead of -3 plus 3y equals 6. 2 times 0 is 0, plus 3y equals 6. That 0 is kind of just gone. If I divide both sides by 3, when I say divide both sides, I put a line here meaning we're making a fraction. A fraction is a division problem. So I'm quite literally just making a fraction out of both sides to divide it by 3. Those go away, I get y equals 2. So when x is 0, y is 2. Now you'll notice the pattern here. I went from negative 3 to 0 on the left side and went down by 2 on the right side. I go up by 3 again. I'm going to go down by 2 on the right side. Let's plot these two. 0, 2 gives me this point. And 3, 0 gives me, oh, look at that. It gives me the same exact point. In fact, you'll notice 3, 0 on this side and 3, 0 on this side. Without even graphing it, I can see that this is the same as this. So my solution is x equals 3 and y equals 0. But to finish the problem, sometimes you get lucky and do that. To finish the problem, I'm going to draw my line. And I'm going to see where they cross, and it's quite obvious that they cross at the point 3, 0, which is the solution set to these two simultaneous equations. X equals 3 for both equations at this location, and y equals 0 for both equations at this location. Now remember, when we did number 1, we made the statement that A has to be the same for both this equation, and B has to be the same for both this equation and this equation, because we're looking for one single number. I'm sorry, we're looking for two numbers, but those two numbers have to be the same numbers. A has to equal A and B has to equal B. All right, so that's what the whole nature of a solution set is. It's where these two lines cross. And our solution set is x equals 3, y equals 0, solving graphically.